This site is known as the Chem Collective. It is a site put together by the Carnegie Mellon Foundation. We'll be using this throughout the year to do virtual investigations, labs, demonstrations, and so forth. When I talk about putting on your molecule goggles, this is what I'm referring to, where you can actually see things happen that you may not get to do in class, or you've done in class, and we want to do repeatedly over time, really on your own or in a lab group. Again, it's the Chem Collective. If we take a look, we have standard virtual lab problems. You have some tutorials, scenarios, simulations. Really nice for looking at in-depth chemistry and the applications of chemistry. Since our tutorial today is on stoichiometry and limiting reagents, we're going to go over here to this site under Virtual Lab Problems to Stoichiometry and Limiting Reagents. When you click on that, you get a page of all of the labs. They are put in a menu format here, and all the categories are together. But when you click on that, it takes you down to the Stoichiometry and Limiting Reagents section. As you can see, I believe there are 4 or 5 choices here. The one I would like you to choose for this particular review is the textbook style limiting reagent problems that has a difficulty of 1 to 2 on the ranking. It looks like 5 might be the overall. We'll get there eventually. To launch the activity, you go over to the right side and see Launch Activity arrow. As you click on that, you will have a virtual chemistry lab window pop up. This is your lab simulator, and this would be as if you were working back in the back on a lab table, a lab bench. In your lab, you would have certain solutions. These are your stock solutions that are over here on the left-hand side of the desktop. On the right-hand side are meters, which we will get to eventually. There's a meter that reads ions and a meter that reads pH. You also have lab drawers, lab benches, in which you could pull out a beaker, Erlenmeyer flask, graduated cylinders, pipettes, volumetrics. And what they'll do is they'll have these stocked with whatever you might need for any particular type of lab you might be working on. The first place you want to start when you come to your workbench is the problem description. It can be found at the bottom of the list, the stock solutions here. Sometimes it will be completely open-ended, and I will have the directions that I want you to follow, and you may not have a problem description. In this case, there's a very specific lab written for this particular workbench, and it has to do with stoichiometry and limiting reagents. In this particular one, it gives an overview of the reaction that will be taking place. An aqueous solution of sodium chloride reacting with an aqueous solution of silver nitrate to produce a precipitate. They show the silver chloride here as being solid and the sodium nitrate as being aqueous. All nitrates are soluble, so that see it in the aqueous setting there. As you scroll down, you'll see this meter. This meter will end up on the right-hand side up in this corner, and it will show your number of ions, concentration of ions. As you scroll down, it gives certain directions that they want you to follow. And even though this looks like it might be a cookie-cutter procedural type, it's pretty open-ended in the way the format is, and it's good like that because it has you being the investigator. I'll show you how to drag the solution out momentarily. Let's look at number 1, A, B, and C here. And in this particular one, it has 3 procedures that you're being asked to perform today. As we go back up here, we're going to use procedure 1A, B, and C as an introduction to how to use this lab bench. So it says solution labeled 1 gram of sodium chloride. I see that up here in my stock solution section. If you look back, you can toggle back and forth between the workbench and the problem description with these 2 buttons down below. So since the problem description tells us that we want 1 gram of sodium chloride, we're going to pull that 1 gram of sodium chloride out, and it is in solution. And I know it's in solution because that I can tell that it's 1 gram of sodium chloride. The volume is 100.344 milliliters. It has very specific concentrations of hydrogen hydroxide, sodium ions, and chloride ions. I go back to my problem, so I've pulled that out. I'm looking at 1B. In 1B, it tells me that it wants me to pull out the 1 gram of silver nitrate, and to that to add 100 milliliters of water. I go back to my workbench. I drag the flask of 1 gram silver nitrate. Notice it's different than the sodium chloride. The sodium chloride, I can see I've got something in the container. It tells me I've got 1 gram of silver nitrate, but I think I need to do something to it. I need to add 100 milliliters of distilled water. So I come up and get my distilled water container, and I like to keep my distilled water container up here. Now I want to get 100 milliliters of water from that distilled water container into that flask. How do I go about doing that? There's 2 ways that I can do this. I can right-click the mouse button on the container. So I just right-clicked on the distilled water container, and I can set that as my source container. If I right-click on the silver nitrate container and set that as my recipient, then the distilled water bottle comes in close proximity to the silver nitrate container. Another way to do that is to just drag, as you would in a video game, drag the Erlenmeyer flask over to the other container, and in touching the two, you should here, maybe I've got them set, I should be able to, yeah, it's not going to let me do that. So I set that as the source, I set that as the recipient, and I'll show you the how to connect those later. I want to transfer, I'm at the bottom now, 100 milliliters of distilled water, and you can hit enter or you can just pour, and I've now added 100 milliliters of distilled water to my silver nitrate, my 1 gram, and now it looks similar to the sodium chloride container. Going back to the problem description, I want to add the 1 gram of solid silver nitrate to the 1 gram solution of sodium chloride. I want to write down the mass of each species. That means you'll have to calculate that on your own. It would be good to get a notepad and paper as you do this, because you're going to have to report back on it later in the Moodle discussion group. I'm going back to the workbench. I want to add the 1 gram of silver nitrate to the 1 gram of sodium chloride. Well, we want to do this just as we would in a lab. We don't want to mix in the containers of my stock solution. So I'm going to add, and I believe if I touch that beaker, I did, I can drag it over as I tried to illustrate earlier, that by dragging the sodium chloride flask over to the beaker I can pour into there. And I know I've got 100 milliliters of that, so let's pour in our 100 milliliters into that beaker. And then I want to pour the silver nitrate, and notice that if I click on the silver nitrate, it tells me over in my solutions chart over here that I have 5.866 times 10 to the negative second molar concentration of silver ions, and my nitrate ions are the same. That makes sense because when silver nitrate dissociates, it's going to be a 1-to-1 ratio. It also tells me my hydrogen ion and hydroxide ion. They're both at 1 times 10 to the negative 7th, which means I have a pH of 7 at this point in time. If I click on the sodium chloride container, I see something a little bit different than silver nitrate. I've got 1.7 times 10 to the negative first molar concentration of sodium ions and 1.7 times 10 to the negative first molar concentration of chloride ions. Okay, so what they want us to do is to take the silver nitrate and pour it into the sodium chloride, and I want to add all 100 milliliters of that. They're showing me a little residue left in the flask because it had a little bit more than 100 milliliters. Now when I click on the container of the two substances mixed together, hydrogen and hydroxide ions have not changed. But the sodium ions are different than they were before, as are my chloride ions. My nitrate ions have a little different concentration now, as do my silver ions. And so this will be the problem that I would like you to investigate when discussing lineage. What causes these particular concentrations? This is what you'll report on the Moodle discussion site underneath Solution Stoichiometry, problem set number 1.